بسم الله الرحمن الرحيم. هذه هي lecture 4 for Nanochemistry 2. راح تكون about chemistry of quantum dot the artificial atoms. نعرفها بالبداية. quantum dots or QD a special class of zero dimension nanocrystal semiconductors with a size ranging between 1 to 10 nanometer or about 10 to 50 atoms on the order of the compound's exciton Bohr radius and with an easily tunable band gap. Then here zero dimension nanoparticles here semiconductors size ranging between 1 to 10 nanometer or 10 to 50 atoms واللي size مالتها تكون on the order of exciton Bohr radius واللي band gap مالتها تكون easily tunable ممكن تغييرها. At these small sizes materials behave differently and have a range of useful electrical and optical properties that diverge in character from those of bulk material. طبعا نتيجة صغر الحجم فراح تتمتع بصفات تخليها تختلف بالتطبيقات مالتها عن bulk material, giving unprecedented tunability and enabling never before seen application to science and technology. فراح تكون التطبيقات مالتها نتيجة هاي الصفات غير مسبوقة بالscience and technology. In general, QD composed of element from periodic table of groups يا 2 and 6 or groups 3 and 5 and groups 4 and 6 وهاي examples عليها. In general, semiconductors are a critical part of many different kinds of electrical circuits and optical applications such as light emitting diode, LED, personal computers and others. السيميكوندكتورز هي طبعا أجزاء مهمة بالإلكترونيكس مثل ال LD, personal computers and so on, or different kinds of electrical circuits. By changing size, shape and composition, quantum dots can change their absorptive and emissive properties dramatically. إذن الصفات مالتها تتغير ويا السايز والشيب والcomposition. The average distance between an electron and the hole in an exciton is called the excited Bohr radius. When the size of the semiconductor falls below the Bohr radius, the semiconductor is called quantum dot. الآن رح نتكلم عن bands and band gaps. هذه الباندز هذه for example conduction bands, هاي valence bands, هاي المسافة بيناتهم distance between them اللي هي band gap. In bulk, energy levels are very close together, so close that they are described as a continuous, meaning there is almost no energy difference between them. It is also established that some energy levels are simply off limits to electrons. This region of forbidden electrons energies is called the band gap, and it is different for each bulk material. Electrons occupying energy levels below the band gap are described as being in the valence band. Electrons occupying energy levels above the band gap are described as being in the conduction band. فالإلكترونز اللي يكونون above the band gap يكونون بالconduction band. Energies يكونون below the band gap يكونون بالvalence band. The band gap separates the valence band from the more energetic conduction band, making it difficult for electrons to jump to the conduction band. طبعا هاي الانرجي اللي يجي هنا الباند جاب تفصل فيكون من الصعوبة انه ينتقل الالكترونز من الفالence band to conduction band. So it is difficult for electrons to jump to the conduction band. In regular semiconductor crystal, the band gap is fixed owing to continuous energy states. يعني يقصد بالسيميكوندكتور اللي تكون in bulk materials band gap تكون ثابتة owing to continuous energy state. In quantum dot crystal, the band gap is size dependent يعني تعتمد على الحجم and can be altered to produce a range of energies between the valence and conduction bands. إذن ما راح تكون continuous في حالة الكوانتم دوت. في حالة البالك ماتيريال الباند تكون continuous. في حالة الكوانتم دوت ما راح تكون منفصلة، فلذلك ما راح تكون مستمرة. لذلك الاي جي راح تتغير في حالة الكوانتم دوت نتيجة تغير هذه الحزم. Electrons and holes. The only way for an electron in the valence band to jump to the conduction band is to acquire enough energy to cross the band gap, and most electrons in bulk simply do not have enough energy to do so. إذا الوسيلة الوحيدة للانتقال من هاي الالكترونز من الفالنس باند to the conduction band هو يتطلب وجود طاقة كافية لهذه الانتقال. Applying a stimulus such as heat, voltage, or photon flux can induce some electrons to jump to the this forbidden gap to the conduction band. فإذا إذا أكو exciting energy such as heat, voltage, and so on, or photons for example, هاي رح تساعد هاي electrons to jump this forbidden energy gap. The valence location they vacate is referred to as a hole. فالمكان اللي فراغ نتيجة هاي الجمب يعرف بأنه هو الهول, positive hole, since it leaves a temporary hole in the valence band electron structure. A sufficient strong stimulus will cause a valence band electrons to take residence in the conduction band. طبعا الطاقة هاي المحفزة اللي قلنا عليها heat or voltage or photons flux تسبب أنه تكون هاي الالكترونز تستقر في conduction band, causing the creation of a positively charged hole in the valence band. طبعا هاي الهولز راح تكون positively charged. The various electrons and the hole taken as a pair are called an exciton. فلما الالكترونز راح تستقر بالconduction bands وتleave these positive holes, هذا البير يعرف بالexciton. There is a minimum energy of radiation that the semiconductor bulk can absorb towards raising electrons into the conduction band. ما بصورة عامة يعني بالنسبة للبulk semiconductor bulk أكو كمية الطاقة هي محددة اللي هي الانرجي جاب حتى تسبب لانتقال electrons من الvalence band to the conduction band corresponding to the energy of the band gap. فهي حسب الباند gap. The band gap energy of bulk semiconductor material of a given composition is fixed وهي ثابتة. As the electron falls back down across the band gap, من ترجع electrons from the conduction band to the valence band back, electromagnetic radiation with a wavelength corresponding to the energy it loses and the transition is emitted. نتيجة لهذا السقوط فراح تنبعث electromagnetic radiation. الطول الموجي مالتها هي حسب الطول الموجي للمسافة اللي قطعتها. Because the band gap of the bulk is fixed, this transition results is fixed emission frequencies. بالبulk لأن هالمسافة تكون ثابتة فلذلك الانبعاث نتيجة هذه العملية عملية رجوع electrons from the conduction band to the valence band تكون emission frequencies fixed. طبعا once again حسب semiconductor. Quantum dots offer the unnatural ability to tune the band gap and change the emission wavelength. طبعا بالباند جاب طالما الانرجي جاب هي tunable ومتغيرة نتيجة السايز فلذلك الاميشن مال electromagnetic radiation أيضا راح يكون متغير. The electrons have a range of energies. Excitons have an average physical separation between the electron and the hole. referred to as the exciton bore radius. This physical distance is different for each material. فلذلك هي صفة خاصة لكل material. In bulk, the dimension of the semiconductor crystal are much larger than the exciton bore radius, allowing the exciton to extend to its natural limit. فبالبulk material تكون ال crystal size أكبر من ال exciton bore radius. However, if the size of the semiconductor crystal becomes small enough that it approaches the size of the material's exciton bore radius, then the electron energy levels can no longer be treated as a continuous. They must be treated as discrete or to be under quantum confinement. The band gap in a quantum dot will always be energetically larger. Therefore, we refer to the radiation from the quantum dot to be blue shifted, reflecting the fact that electrons must fall a greater distance in terms of energy and thus produce radiation of a shorter and therefore lower wavelength. طبعا بالsmaller size the quantum dot دائما الانرجي جاب تكون أعلى فلذلك تكون هي أكبر يعني electrons must fall a greater distance لازم تقطع لمسافة أكبر in terms of energy and thus produce radiation of shorter and therefore lower wavelength. طبعا لما تكون الطاقة أعلى معناتها الwavelength يكون أقصر فلذلك يكون blue shifted. هذه هي ال discrete energy levels نتيجة للquantum confinement. هاي بالvalence bands وهاي بالconduction bands. هاي هي الholes positive holes and electrons the distance between them هي exciton bore radius. قلنا exciton bore radius هي صفة خاصة بالmaterials فلذلك for example هاي semiconductors for example for CDS exciton bore radius diameter هو 56 angstrom بالانرجي تعادل ما يعادل 2.53 electron volt and so on. So مثل ما نشوف إنه كل semiconductor إلى exciton bore radius الخاص به فلذلك إلى band gap energy الخاصة به. The band gap separates the valence band from the more energetic conduction bands, making it difficult for the electrons to jump to the conduction bands. فإذا الباند جاب هي تفصل ما بين valence band والconduction band would make it difficult to electrons to jump from the valence to the conduction band. In a regular semiconductor crystal, يعني bulk semiconductor crystal, the band gap is fixed owing to the continuous energy levels. In a quantum dot crystal, the band gap is size dependent. يعني تعتمد الباند gap هنا تعتمد على size and can be altered to produce a range of energies between the valence and the conduction band. Quantum mechanics dictate that the band gap of a quantum dot will always be larger in magnitude. حسب ميكانيك الكم دائما ال EG أو الباند جاب تكون دائما الكوانتم دوت أعلى من البulk material. The band gap the minimum energy necessary to excite an electron from the valence level to the conduction level of a semiconductor crystal or quantum dot is given by the equation هاي. نشوف إنه هنا ال EG for the quantum dot equal to EG for the bulk plus هذا الترم h bar square pi square divided by 2 mu r square where the second term اللي هو هذا describes the energy levels of a particle of mass mu in a spherically symmetric potential box. فإذا هذا هنا هو السايز والماس مال particles. obviously كل ما هذا الحد يصغر معناته هذا كل الترم يصير أكبر، فلذلك الإيجي الباند جاب هنا راح تصير أكبر. The equation above explains qualitatively well the quantum size effects in the quantum dots. The increase of interband energy separation with the decrease of a quantum dot size. The conduction band. This band contains the energy level that are above the band gap and higher. Because the band gap is always much larger than the distance between energy levels, not many electrons can jump to the band gap and cross into the conduction band from the valence band. إذا انتقال من valence band إلى الconduction band يعتمد على الباند جاب نفسه. بس هنا عندنا ال continuous band، هاي في حالة طبعا البulk، وال discrete band في حالة ال quantum dot. Continuous bands, the set of physical conditions where energy levels are separated by such a small amount of energy that for some processes they may be treated as if they were not separated by any energy amount at all. يعني كأنها تكون متصلة. The band gap of a material may be treated as fixed and unchangeable لأنها تكون continuous. في حالة ال quantum dot هنا عندنا ال discrete energy levels, the set of physical conditions where energy levels are separated by enough energy that the addition or subtraction of one atom or electron to the crystal will measurably change the energy of the band gap. فتكون هنا source of يعني الانفلاقات الطاقية نتيجة للسايز في الكوانتم دوت. Energy levels بصورة عامة, the result is that any crystal electrons will start falling the lowest energy levels first. طبعا اعتيادي الأوطى مستوى الطاقي هو اللي يبدأ بالامتلاء أولا, and continue to fall levels with higher energies until no more electrons remain without energy levels. Exciton. An exciton is the term used to describe the electron-hole pair created when an electron leaves the valence band and enters the conduction band. إذن هذا الpair electron-hole pair called exciton. Exciton have a natural physical separation between the electron and the hole that varies from substance to substance. This average distance is called the exciton bore radius. فالمسافة ما بين الالكترونز والهولز تسمى بالexciton bore radius. In a large semiconductor crystal معناته بالبulk, the exciton bore radius is small compared to the crystal, and the exciton is free to wander throughout the crystal. فطبعا بالكريستال بالبulk راح تكون الexciton bore radius صغير بالنسبة للكريستال أو particle size, ذلك يكون free to wander يتنقل throughout the crystal. In a quantum dot, the exciton bore radius is on the order of the physical dimension of the dot or smaller. راح يكون حجم مالته مقارب. هذا الراديوس راح يكون الحجم مالته مقارب للدايمنشن مال dot or even smaller. And the exciton is confined, لذلك راح يكون هنا مقيد. This second set of conditions يعني هاي sets is called quantum confinement, which is synonym with having discrete يعني non-continuous rather than continuous energy levels. Exciton bore radius. This is the natural physical separation in a crystal between an electron in the conduction band and the hole it leaves behind in the valence bands. فهي المسافة ما بين electrons in the conduction band and the holes, the positive holes, these electrons leaves in the valence bands. The size of this radius controls how large a crystal must be before its energy bands can be treated as continuous. Therefore, the exciton Bohr radius can rightly be said to define whether a crystal can be called a semiconductor, quantum dot, or simply a bulk semiconductor. فمعناته باختصار إنه السيميكوندكتور هل ممكن اعتباره هو bulk أو ممكن اعتباره هو quantum dot على السايز مالته. فإذا السايز مالته كان مقارب للإكسايتن بور راديوس معناته هو quantum dot. Otherwise فهو bulk semiconductor. Quantum confinement. The quantum confinement is the set of conditions under which a crystal is on the order or smaller than the exciton Bohr radius for its constituent component. Under quantum confinement, energy levels must be treated as discrete. معناته الانرجي level بتكون غير مستمرة، بتكون منفلقة discrete. By definition وحسب طبعا هذا التعريف quantum dots are in a state of a quantum confinement. معناته quantum dot هي في حالة من quantum confinement. Semiconductors, a material with electrical properties resembling those partially of insulators and partially of conductors. فإذن هي الماتيريال اللي تكون المواصفات ما بين الانسulator العوازل وما بين الموصلات. The application of external stimuli such as heat or voltage can radically alter the conductivity of a semiconductor. فإذن أي excitation خارجي for example they can heat or voltage يؤدي إلى تبديل أو تغيير التوصيلية لهذه المواد. Semiconductors, especially silicon and germanium, are the cornerstone of the modern electronic industry. فإذن هي من الأساسيات في modern electronic industry. Valence band. This band contains all the electrons from the one with the lowest energy to the one with the energy just on the lower edge of the band gap. فإذن الفالنس باند مثل ما شفنا بالسلايدات السابقة إنه هي تكون beneath or under the band gap. Since electrons tend to occupy energy state with the lowest energy possible, the valence band's energy levels are usually almost completely full. Application of quantum dots. Quantum dot formulation are so important for future applications and can create opportunities in a range of global markets, including displays, life sciences, thermoelectrics, photonics and telecommunications, security, solar cells and photovoltaics, biology, biosensors, imaging, light emitting diodes, LEDs, quantum computation, flat panel displays, memory elements, photodetectors and lasers. Preparation of quantum dots. There are three main ways to confine excitons in semiconductors. Confining excitons in semiconductors معناته preparation يعني تحضير quantum dots. For example, by using lithography, colloidal synthesis, or epitaxy, pattern growth or self-organized growth. هذا example. طبعا هاي example فقط حتى نبين إنه هي فعلا يعني ممكن بطرق مختبرية بسيطة ممكن تحضر quantum dots. For example هنا preparation of CDSE quantum dots طرق مختبرية. For example هنا they emphasize because of the size of nanoparticles depends on reaction time, start timing when selenium solution is added. هنا دائما في تحضير هي صح طرق مختبرية لتحضير nanoparticles بس تكون under a controlled manner. دائما timing the temperature highly affects the growth of nanoparticles فلذلك لازم يكون مسيطر عليها ومحسوبة. فلذلك هنا مثلا قايل because of the size of nanoparticles depends on reaction time, self-timing when selenium solution is added.